Now let's see this question. Now we have a code given and we want to find out the output of this following code. Okay, what is the execution of the code if n equals to 2 power 40? Okay, now let's see here. Now here unsigned long int and n has been passed in this function, and now let's see the following 3 lines and execute this code. We have 2 for loops, for loop 1 and for loop 2. We'll get in the for loop, first for loop, and put I equals to 2 power 40 because n equals to 2 power 40. And let's check the condition first. In the first iteration we have 2 power 40 is greater than 1. Yes, it is true. Then increment the value of j because we want to get inside the loop and increment the value of j, and now I will become 2 power 39 because 2 power 40 divided by 2, which gives me 2 power 39. And the next iteration do the same thing, test the condition I, which is 2 power 39 is greater than 1. Yes, correct. Increment j and 2 power 38 because we have to divide it by 2. Okay, now if you continuously do this and the last 2 loops, it will be like this. Test 2 power 1, which is greater than 1. Yes, 2 is greater than 1. Yes, correct. J equals to 40 and I equals to 2 power 0. And in the last iteration it will be false because 2 power 0 is not greater than 1. And we have to close the loop. See, here's the trick. In this case, if you see a proper pattern is been repeated continuously, the pattern is here 40 is there and there is 1. If you add them, it will be 41. And if there is 39 and there is 2, if we add them, it is 41. And if we do this for entire iterations, it will be like j should be 40 when 2 power 1 has been used here. So also notice here j is 1 and there's 39 plus 1 is 40, 38 plus 2 is 40. It should be 0 because 40 plus 0 is as usual 40. So you need not worry about it. Directly the value of j equals to 40 and I equals to 2 power 0, and close the loop. Here we got j equals to 40. Now come here in the for loop 2. Now you need to test the condition j is greater than 1. Yes, 40 is greater than 1 and sum has to be incremented because sum was previously 0. Incremented, sum equals to 1, and we need to divide j by 2. It gives me 20. And next loop, test condition for in the loop 20 is greater than 1. Yes, correct. Increment sum, and again 10. Test the condition sum 3 j5 and continuously go there in the for loop. In last condition we need to close the loop after you getting a sum of 5. Okay, so return sum, which is 5. The answer is 5. Now let's say this question, count xy, and it's a if statement given in nested, and we have to print star if y is not equal to 1 and x is not equal to 1. Then we have to print star count x by 2 comma y, and this condition is not happening, then else y equals to y minus 1. Let's see the loop. Now we need to figure out the output of the program if we use count 1024 comma 1024. Here if we put the values, then x equals to 1024 and y equals to 1024. Now y is not equal to 1. Okay, then we have to execute the inner statements. So here if x is not equal to 1, here x is 1024 and 1024 is not equal to 1, go to the inside loop and print star, and then the call count 512 comma 1024. Why 512? Because x by 2, which is x is here 1024 by 2 is 512. And if you do continuously the following statements, the star will be printed 10 times. If you notice here, count 512 comma 1024 will also call this print star, and then again count x by 2 comma y, which is x is here 512 and x by 2 is 256 comma y. Y is remaining same for all the calls except that x is decrementing with the factor of 2 at each iterations. Okay, at the last when we got the count 1 comma 1024, here x is 1 and y is 1024. Here in this case we get inside the loop, inside the if statements, and the else condition has been executed. Here y was 1024 and we decrement it by 1, so we get 1023, and we keep on going with the value of 1023 for y. And now again, if you watch in the second statement, we have count 1024 comma y. Okay, we get here 1024 comma y is now 1023, and if you continuously do this, the same steps as we have done in the previous iteration, you get again 10 stars. Okay, and if you continuously do this the different number of passes until and unless y becomes 2, it will print 10 stars at each iteration, and after you get at the end, you get y equals to 1. And if you call count 1024 comma 1, you get do nothing. So how many iterations we have executed? From 1024 up till 2, we have 1023 iterations. If you subtract and add 1 to it, you get number of iterations. And how many star has been printed for each iteration, which is 10. So you can get 10230. Okay, now let's say this problem. Figure out the output of fun5 when executed in the C program with the two functions f1 and f2. We begin from the main function, and main function calls f15, and here n is 5, because if we are mapping a function of 1 with this function, and we have some statements to be executed. And now in this statement we have, firstly we print the n value, which is 5. Okay, and now call function 2 n minus 1. Here n is 5, 5 minus 2 is 3. We then call function 2 of 3. And now in this second statement we have the printf %d n. Here n is 5, so we have marked here 5 to be printed at the last. Okay, it means our answer should start with 5 and end with 5. Okay, and we have two options, A and C, that does the same thing, start with 5 and end with 5, start with 5 and end with 5. Now let's execute function 2 of 3. Come here, n is not equal to 0. Okay, it's fine, do not return anything. Print n. What is n here? 3. Print 3. And now we have to call function of 1 with the re-increment of n and then placing it. It means that increment the value of n and then place it. First increment the value of n. What is the value of n here now? 3. Increment by 1, which is 4, and then place it. Okay, function of 1 n. Also use the fact that printf n. What is the value of n now? 4. So just mark here 4. But here variable n in both the functions is not static, it is automatic. It's automatic, we are placing the value itself. But if it would have been the static, we could have left the value as blank and fill up the blank at the last of the execution. Okay, now let's figure out the value of function 2 of 2. It will be 2, printing the 2 here, and also we have the pre-increment and then call the function 1, 3 and 3. Okay, this will go repeatedly until the base condition achieves. Okay, now let me see what is the output of the following code until now. See, it will start from 5342. Okay, 5342 is same in all the cases, but it will end with 3445. Okay, so 3445 will be this. Okay, so this A option is right. Now let's solve this problem. We have a main function with 3 statements: character star x, abc, character star y, def gh. These are the two strings, and x is a pointer to a character, okay, to a strings, and y is also a pointer to a character, and we need to execute this print length x comma y. Now x is this string and y is this string. Put these strings in this place, in the respective place in the formal parameters, and now we have unsigned integer c, which is equal to 0, and also a integer length. Okay, it is integer length which states as a ternary operator that if this statement becomes true, then execute strlen x s, and if it is false, strlen t would be printed, and at last len should be printed in the screen. Now consider the base address for the string abc is 100 and the base address for defgh is 200. We take the base address and put it into the println function like this, 100 and 200 respectively. Now we have a initialization of c which is equal to 0 and length equals to the strlen s which is 100 place here, strlen t which is 200 place here. Just replace the s with 100 and t with 200 and solve this. strlen of 100, see this function strlen goes to the base address 100 and counts the number of characters 1, 2, 3. It will return 3 here. Okay, and what about 200? 200 will return 5. 1, 2, 3, 4, 5. It will not count the null and place here. And if you subtract these two numbers, it will be -2. But since the strlen is a function which returns an unsigned integer, the answer to this evaluation is also an unsigned integer, and -2 in unsigned integer would be equal to maximum -2, and which is obviously greater than 0. So this statement will become true and 3 will be assigned to len 3. Now you have to print the value of 3 in the output. So you will see 3 in the screen. Now let us solve this problem which came in GATE 2017 set 1, and we have two functions. First is total and second is the main function. We will start from the main function and execute it. Okay, we have a static variable x which is of type integer and it is assigned with 0, and an integer which is I equals to 5, and I have a for loop. So if we come here, we will get into the loop because I is 5 and I is greater than 0, which is 5 is greater than 0, true. So come into the loop and x equals to x plus total 5, and now we have to execute total of 5. We come into the total function and we have another integer variable which is count, and it is also statically defined and assigned with 0. While loop, we are continuously executing this two statement until and unless this while statement is false. It means that until and unless v is equals to 0. Okay, now come here. Now count is initially 0, and now we are going to execute the while loop, and the first statement is count plus equal to, which is a compound statement, and we want to expand this as count equals to count plus, it is a bitwise AND between v and 1. Now initially v is 5. Okay, now we have written it in binary 0 1 0 1, and also it is bitwise AND with 1, and 1's binary is 0 0 1. It is 1, and if you do the bitwise AND, it will be 1. Okay, so this value is 1, and initially count was 0. 0 plus 1 is 1, so count equals to 1. Okay, in the first pass it is count equals to 1. And what is the meaning of this statement? V right shift equal to 1. It means that if we want to expand this, it is also a compound statement, and we want to expand it like v equals to v right shift 1, v right shift 1. So we have this v equals to, what is value of v now? 5 right shift 1, which gives me 0 0 1 0. If you see the notations like slash sign, it will show you how the shifting has been done. Okay, now you approach 2. Why? Because it is a binary of 2, and obviously the right shift is a division operator, and if you divide 5 by 2, it will give you 2 in integer. And in the next iteration, this while loop became again true because v is equal to 2, and if 2 is placed here, it is true. Now we execute the first statement of the while loop, count plus equals to, again the bitwise AND. So like this. Now initially count is 1. In the previous iteration the count was 1, place 1 here, plus bitwise AND of 2 with 1, as we have done in the previous iteration. Bitwise AND of these two values binary is 0, So 0 plus 1 gives you 1, and do the right shift again, it will give you 0 0 0 1. See, if you shift it by 1 to the right, it will give you 0 0, and again a 0 would be placed here, and 1 will shift it to the LSB. Okay, here. Now in the next iteration, count equals to 1 plus bitwise AND of this one with the 1. It will give you 1, and this one plus 1 will give you 2. It is the execution of total of 5. Total of 5 value is 2, so 2 plus 0 is equal to 2. X is having the value of 0, so 0 plus 2 gives you 2. Now if we come to the for loop, and now I is decremented by 1. Now I becomes 4, because previously the I was value was 5, and now it becomes 4, and we place this 4 in this place, because 4 is greater than 0. It becomes true, and we have to execute this statement. X equals to x plus total of 4. Okay, this one. And now if you notice one thing in the previous iteration, why the value of count became 2, because we have number of ones equals to 2 in the case of 5. In this case, 5 is having a binary of 0 1 0 1. We have 2 ones here, that's why the value of total gives you 2. But in case of 4, it is only 1, so it should give you 1. But remember one thing, the value of count is 2, so you have to count the number of ones after 2. How many ones are there? Only 1. So 1 plus 2 is 3, so the total of 4 should be 3. Okay, let me execute a total of 4. So initially the count was 2 because it was a static variable, and now count plus the bitwise AND. Count is 2 plus bitwise AND of 2 with 1 gives you 0. Okay, 2 plus 0 gives you 2. In the next iteration, it is the while loop becomes true, and you need to calculate count equals to count, which is 2. It is coming from here, plus the right shift of bitwise 2. Okay, this shifting will like this. 1 will get shifted towards this, towards the right, so it will become like this, 0 0 1 0, and it is again bitwise AND. It will give a 0. 2 plus 0 gives you 2. In the third iteration, count equals to count, which is 2 plus the again this right shift of 1 to the right, and again the bitwise AND with 1 gives you 1. 2 plus 1 gives you 3. In the next iteration, I will become 3 because it will be decremented, and total of 3 will be executed. Now total of 3. Now initially count is 3 as a static variable, and 3 has a binary of 0 0 1 1, and number of ones are 2. Add 2 to the 3, you get 5. 5 is value is placed in place of total of 3, and value of x becomes 10. In this way you can solve this problem completely. After the I is decremented by 1, I becomes true, and if I becomes 2, total of 2 becomes 6, because previously the count value of 5 was 5, and 5 plus 1, because number of ones is 1, and the count becomes 6. 6 plus 10 becomes 16, and in the next iteration I becomes 1 because of decrement, and total of 1, and the initially the count was 6, and 6 plus 1 becomes 7, because number of ones is 1. 1 plus 6 becomes 7, and 7 is added to 16 becomes 23. And when the I becomes 0, 0 is greater than 0, false, you will come and arrive to execute this statement, and x becomes 23. Okay, and if you are new in my channel, please subscribe my channel. I will make videos like this, and if you like the video, please like my video and share to your friends if they need it. Thank you.